Hello, hello. राहुल राहुल देखना ऑडी वाला यहाँ बाहर खड़ा होगा, बोला यार क्या कर रहे हो? इधर इधर इधर। नहीं, वो तो उन लोग को आइडिया नहीं ना सर ऑडियो का। हेलो हेलो। Good afternoon, everyone. Welcome back. It's my pleasure to introduce our keynote speakers, Mr. Manoj Kumar Das sir, who brings over 17 years of extensive experience in IT industry. Currently serving as a project manager, Mr. Das has made significant contribution to leading organizations such as FIS, Cognizant, SunGuard, and Reliance Technology. Throughout his career, Mr. Das has developed a deep expertise in various domains, including Linux and Unix shell scripting, Python scripting, Skybase, Oracle, MongoDB, and DevOps. His technical proficiency and leadership has been instrumental in driving complex projects to success, and his insights into the integration of these technologies within the realm of computational material science will undoubtedly be invaluable. Also, we have with us Mr. Chetan Arora sir. I am delighted to introduce sir, who brings over 12 years of rich experience in IT industries. Throughout his career, Mr. Arora has worked with prominent organizations such as SunGuard, Central, etc., showcasing his expertise in Unix shell scripting, Linux. Hands-on experience in these areas make him a valuable resource for understanding the intersection of IT and computational material science. Please welcome both of these with a huge round of applause, please. Check. Good afternoon, everyone. Food all eaten, all set. Anyone feeling sleepy or something? All good? Okay. So to start with, I'll start with a famous saying, which is change is the only thing that is constant. How many of you believe that? Since the time you have grown physically, mentally, intellectually, your knowledge has grown, your way of working has grown, and you must be nostalgic about your old days, how you used to be, and you would have thought that let the time be still. I don't want to move on, but that's not how life goes, right? It keeps on changing. Since the beginning of the time, we have been evident of the changes around us. If we look at human history, humans have been exploring, experimenting, and finding out ways to perform tasks in different manners or a better approach. Repetition is something that we don't like. You all would agree, right? So we are born with curious minds. We are born with the inquisitive mindset, and that's what the core nature is. That's what the nature of universe is, and it is going to be the time we are existing, and it shall be when we will extinct. We change our way of living, wearing clothes, communicating with each other, traveling, studying, entertainment, sports, and this is our core nature. From walking on the roads to flying around the planet and then exploring the space. From studying with slates and chalks, we have moved to tabs and stylus. From navigating like nomads to using applications like
Google Maps and Apple Maps to reach our destinations, talking with each other on postal emails, to emails, telephones, video calls, and these are just to mention a few. And now come the computers in the early 90s when we were fascinated with the technology, Pentium 1, Pentium 2. We were also excited, right? Then came Pentium 5, and we keep on upgrading the system since then. Now, when we are tired of it, we want the machines or the computers to be intelligent like us. We want them to perform tasks that we perform in our daily lives and with the same accuracy. Today, we want everything in a jiffy. Like we just want to have, we just want a task to be done right now. Everything accurate and precise. So, my dear students, fellow speakers, today I, Chetan Arora, along with Mr. Manoj Das, we invite you on the exciting and a mysterious journey of AI and ML. Let's start. To begin with, what we are trying to achieve here is a goal that says artificial intelligence should think like us, should have intelligence like us, should make decisions like us, and to solve our daily life problems. We basically want to automate everything. Machine learning, which is just a part of AI, focuses on developing some algorithms and statistical models that enable the system to perform those tasks effectively without being explicitly programmed. How many of you have written program in C or C++? Maximum lines, maximum number of codes, I mean 200, 500, how many? Any answers? 2,500 lines of code. That actually involves a lot of time, a lot of energy, a lot of brainstorming, and of course, a deep knowledge of syntax as well. But nowadays, we just give an instruction to Google that we want to go to a particular location, and it helps us to provide a route which is less crowded with less amount of traffic along with an ETA. So how does Google Maps do that? Anyone want to try? Like what's happening behind uh, the Google Maps? So basically, the machine learning and the intelligence that plays its role at the background studies the road conditions, the climate conditions, the behavior of traffic, the behavior of your driving, the route, the distance, and then it suggests us a suitable path to reach our destination. And while we are on that trip, it sometimes also suggests us a less crowded path, a faster path, saying that we have an alternate route which is 4 minutes faster, which is 5 minutes faster, something like that. While we keep on routing to a destination and enjoying our trips, Google and the machines does their role at the background. So that's what AI and ML is. And I can understand that these terms could be very much confusing because these are interrelated. These are some fancy terms that we use: artificial intelligence, machine learning, deep learning, natural language processing, and they can be quite intriguing and confusing for you guys. So let me put it in a very simple way for you. The amount of AI that you guys are interacting nowadays is just a weak AI. It's not something that we have thought of achieving as of now. It's just a no voice. It's just the very beginning of it. Through AI, people wanted to achieve a goal where machines would have consciousness and sentience, just like humans. That's when we would say that AI is completely achieved, and it still has a like a very long path to travel. What we are dealing with right now is the very basic of it. It's not even the 5% of it. That's why we call it a weak AI. This diagram that you see will help you understand how all these things are placed. Artificial intelligence as the father of machine learning, expert system, speech recognition, planning, robotics, vision, natural language processing. It holds all of these branches under one root. Today, we'll be focusing on machine learning and natural language processing. Now, due to the time constraint, the time we have been allotted here, it's not possible to even cover up one single subject because these are vast, deep oceans of knowledge. And my goal here is to provide you the basics, at least from where you guys can start being the material science students, in order to improvise the way you have been working. And you would also know how things are going around in material science across the globe, how they're using AI and ML, how they're using Python in order to achieve the same task at a much less time with more efficiency and more precision. I'll go to the theoretical part of it to give you a gist of it. Machine learning is a subset of AI that focuses on developing the algorithms and statistical models that enable system to perform specific tasks effectively. Any one of you, what is an algorithm? Can anyone define an algorithm? Yeah, please. Define set of instructions. That's correct, but there is one important aspect to it. It must follow some rules. So the steps are involved to perform a particular task, but also it has to follow certain rules. So for all kinds of tasks that we have today, we have different algorithms already designed, and we are creating even more. The deep learning is a specialized branch of machine learning that uses artificial neural network, just like our brains that has a neural network. So we are trying to establish an artificial neural network with multiple hidden layers to learn and make predictions of complex data. That's why the term deep learning, because it has stacks of deep layered neural networks. And language processing is a field of AI that focuses on interaction between computer and human language, enabling machines to understand, interpret, and generate human language. I'll get into details of all of these in the following slides. I just want to share something with you to have a better picture. As I already told you that the goal of AI is to achieve human consciousness and sentience. And this has been attempted since 1950s, where a lot of investments are being made, a lot of research is being done. While we came across artificial intelligence in like a couple of years ago, and we think that it's very new to us, but its history goes back to 1950. So to understand machine learning, the basic literal term is that we want the machines to be trained to learn from the experiences just the way we learn as a child, and as we grow up through our different experiences, through our failures, through our success, we learn different things. That's what we want a machine to do, to have its own consciousness, to have its own sentience, so that it can make decisions on its own, it can perform tasks on its own, keeping aside all the emotions. How many of you trade in Bitcoins? If you want to disclose that, don't worry, I'm not going to steal your money, but let's hear it out. But have you heard of cryptocurrencies and Bitcoin trading? You have heard it, right? Nowadays, it is being outsourced to artificial intelligence, the Bitcoin trading. Like you train a machine, you train a computer with some code, and it will automatically predict patterns for you, whether the Bitcoin value is going to go up or it's going to go down. And that's all being done autonomously. So say you have to make a software for Bitcoin trading, and you know the exact algo that can give you the desired output. So by desired output, I mean it will give you a prediction that the Bitcoin is going to go up or down, and based on that, you're going to trade the Bitcoin, right? So you make an algorithm, and that algorithm takes some inputs, required values, and gives you the desired output. Simple as that. This is very normal. This is, you have given some input, you have given some outputs, and you get the results. That's completely normal learning. Now, in reality, if I talk about Bitcoins, what are the factors that basically decide the uptrend or the downtrend of the Bitcoin? Factors like Bitcoin movement, there are a few indicators as well, graphical history, comparison of historical movements of the Bitcoin. All these factors come into consideration. And if I asked you to figure out, to deduce some mathematical formula that will take all of these things as input and give it a desired output, you won't be able to do that, right? It's difficult to deduce a mathematical formula to give you the uptrend or a downtrend of the Bitcoin. So what you do, you make a program that will randomly take input of all these values, the Bitcoin movement, the graphical movement, the indicators, comparing the historical values. It will take numerous amount of these inputs, keep working hard to provide you more accuracy. With more accuracy is to predict the right trend, whether it's going up or whether it's going down. A simple hit and trial method. Now, when a machine starts to do that, it also starts to learn that whether it is making a right prediction or a wrong prediction. And based on that experience of the input values and the outcome, it keeps on learning and keep improving itself. That's what actual machine learning is. And that's how normally we as human learn. We do some task, we do it with some efficiency, we might fail, we try again, we improvise ourselves, we improvise our approach, and then we again perform that task. And that's how we learn. That's what we expect machines to do. That's how AI, ML are interrelated. And that's what we want to achieve. So talking about natural language processing, as the term suggests, we speak Hindi, English, Odia, Punjabi, Spanish, French. There are n number of languages across the globe. And you must have seen some conferences where people of different regions join together with an equipment attached to their ears, and they can listen to the conference in their own native language while the speaker is speaking in his own native language. The most famous example is our very own Honorable Prime Minister, who gives speeches in Hindi, while the people sitting in the audience, they understand each and every word. That's what machine learning, that's what natural language processing does. I'm just giving you the gist of it, that once you start your journey towards learning all these concepts, at least these are the things that you need to deep dive into, basically. And this graph here shows you the exact picture of how these things are placed, how these are interrelated, how they are subset or superset of each other, and how you can plan your journey towards learning these things. because this is the way forward. Things which are outdated or not in use, they are obviously eradicated, eliminated, while we adopt new methods of learning. In 90s, we used to go to the banks to withdraw our money or deposit our money. And nowadays, we have come to a simple clicks on our smartphones through UPIs, we transfer money. There is no need to go to the banks. And that's how lazy we have become. We don't want to go to the banks, right? We just want everything to be done while we are sitting at our bedside. I'll discuss a few practical applications of AI and ML, like image recognition. All of you must have used Google Lens. You click a picture, you search it on Google, and it will tell you the exact location or the description of what exactly it is. Natural language processing, I have already discussed. Predictive analysis. All of you see cricket, and there is a statistics that is shown at the bottom of the screen which says projected score based on the bowlers, based on the batsmen, based on the wickets in hand, based on the climatic condition and the pitch report. They deduce how many runs are going to be scored based on the previous match updates and the runs that were scored on that pitch earlier. So that's where prediction analysis comes into picture. And autonomous vehicles, of course, everyone knows about Tesla. Now even the Indian brands like Mahindra and Tata have come up with ADAS 1 and ADAS 2 technologies in their cars. But again, if you think these are AI generated cars, I would say you are totally wrong, because we have just started implementing these things. There is a whole lot undiscovered potential that is yet to be achieved. So we all know about general purpose languages. We all know about low level, high level languages that we use to communicate with computers. You must have used C, C++, Java. All of these give commands to your computers and the computer performs the task. But in order to deep dive into AI and ML, Python is the best available option that we have today. And there is no other alternative to it. The way Python is delivering through its resources, there is no match to it. So why Python for AI and ML? Just now someone said 2,500 lines of code in C, C++, right? Imagine that task being done in not more than 40 to 50 lines in Python because of its extensive libraries and expressiveness. So how does Python do that? There are pre-written libraries, codes, which are already present in Python. They come as package, which you can import, and you don't have to write all those number of lines or codes and, get your time consumed there. So versatility and expressiveness, extensive library and framework, and rapid prototyping. Can anyone tell me what prototyping is? Prototype? Anyone? Normal English word? The experimental product. Very good. It is the product that we have as a test before having the actual product in our hands. And that's where Python helps us in rapid prototyping, where a developer writes a code as a prototype for the application, and then he or she can immediately, once the test is done successfully, they can rewrite the code in their desired language. So that's where Python helps in prototyping as well. The most important, the Python libraries, which makes it apart, which makes it class apart and top of the chart from all the other general purpose languages that we know today. Now, here we mention about 10 Python libraries that you can see: TensorFlow, scikit-learn, Pandas, and NumPy. But these are just to name a few, which are important ones, which you might be using in your material science projects. But there is a vast variety, vast ecosystem of Python libraries and frameworks that are solving problem like anything. That's why it is the first choice for NASA, for investment banks like Credit Suisse, Citibank, Morgan Stanley in their fraud detection, because it eases the work like anything. Just to give you a brief about these things, like TensorFlow is an open source library for numerical computation and large scale machine learning. Scikit-learn is a machine learning library that provides simple and efficient tool for data mining and data analysis. Pandas are used for data manipulation and analysis library that provides high performance, easy to use data structures and data analysis tools for working with structured and time series data. And NumPy, fundamental library for scientific computing in Python. Just to name a few, like the ones with which you can start learning Python, because once you have the basic technical aspects of Python, which will be covered by Mr. Manoj Dash, after that, when you explore the libraries, these are the ones that you can start with. So, algorithms, that is the key for working of AI, because that's what is being used to perform tasks through AI. We need algorithms. And categorically, they are divided into three categories. You can see supervised learning, unsupervised learning, and reinforcement learning. I'll explain each of them a bit in detail so you can relate it to your daily lives. Like, we all know algorithm is a set of instructions that are given, but they follow certain rule, and accordingly they perform a particular task. Now, if we talk about supervised learning, it is the algorithm that are trained with some labeled data as input, and the desired output is also fed. So, for example, let's say we want to predict the price of a house of an area, right? Before we let the machine do that prediction, we have to provide a lot of input data and the desired output. Let's say we give 20% data for testing purpose and the remaining 80% of that data for training purpose. So for house prediction, we require data like the features of the house, the price of the house, the number of rooms in the house, and the basic house details, the location and everything. And we have to give like the data of thousands of houses with the desired outcome. And then the machine will learn to predict that with so many features, what should be the exact price of the house. Spam emails. We all are aware of spam emails. They have grown up with the current time. So data scientists classify different parameters to differentiate between official and spam emails by training the databases. And what databases do? They take all of that data, they study the pattern of a regular email and a spam email, and when a new data comes into picture, a new data means a new email comes into picture, they analyze it, they understand whether it's a spam or a regular email through the content it has studied earlier. Sentiment analysis, and this is very interesting. All of you must be using Amazon and Flipkart's e-commerce websites to buy products. You go to some place and your Google asks you to review that place. And that review is used as a data by the e-commerce companies. They identify the sentiments of customers via product review. So based on how you have rated a product, whether you liked it or not, it suggests you more or more products, or it completely remove that category from your suggestion list. So we don't even know, but AI and ML are already, they are part of us and we are using it. Supervised learning, and then now the unsupervised learning, where it basically focuses on the pattern of the data. Let's say we have an entity like you all are students, and you all go to a premises with authorized access to it, while one of you or two of you might not be having the access to the building. So that's a security breach. You guys are not allowed there. In unsupervised learning, it discovers a pattern in data without any prior labeling or categorization. It will only understand the pattern of a large entity, and based on that, it will detect anomaly or a human error. And that's how the breaches are confronted. Another example is Google News. It categorizes news into the same story from various online sources. For example, if you example could be result of presidential election. If you search that under US news, if you just search the term US news, it might give you presidential elections in the list, and maybe some other prominent news from the same country. So that's how it categorizes the news of the same story and gives you in your feed, in your smartphones. Then unsupervised learning is also used in medical imaging, in radiology and pathology. And anomaly detection, I have already told you, where human errors are detected and security breaches are detected. And last but not the least comes the reinforcement learning, which works on the principle of a good move or a bad move, mostly used in games, where the agent is rewarded with all the right moves and it is punished, or a penalty is there for every wrong move. The most common example is the suggestions you get in your Amazon Prime and Netflix recommendations. Based on what content you have seen, based on what content you have liked, it suggests you more of such content. So this is just the very basics of it to give you a broader picture, a blueprint from where you guys can start and start exploring these concepts and use them in your primary subjects. So from now, things are going to be a bit technical, but just stay with me. I'll explain everything, and you don't need to go deep dive into it, but we'll just explore these algorithms a bit more in more technical terms, and I'll explain you line by line how things are being done. If we consider an example of supervised learning, it consists of mainly 6 steps. First is the problem statement. Let's say the problem statement is to whether an email is a spam or not. So firstly, it will use Panda, the Python library, to collect all the email data, the subject, the body, the content in the email. And then comes the data pre-processing step to clean and prepare the data, handling missing values, encoding categorical features, and performing any necessary feature engineering. And then comes the model selection, the models we talked about earlier. Based on the data that we have, it will choose a suitable classification algorithm, such as logical regression or decision tree. Now, these are the examples of models that will be used. Once you will learn these things step by steps, you will understand. And to predict whether an email is spam or not. Once the data is selected, once the model is selected, now comes the phase of testing and training. So we use scikit-learn to train the selected model on the pre-processed data, optimizing hyperparameters as needed. And finally, model evaluation, how the model performed, how much accurate it was in identifying whether an email was spam or not. This is just a theoretical explanation to everything that we see. Okay. So what we see here is a sample program. Seems a bit scary, right? Understandable or comprehensible by anyone. But I'll go line by line. So don't look at the entire program at one go. We'll just focus on the first 3 lines from it. This is all written in Python. Okay. The first step includes, if you see the keyword import in between, that means it is importing something, right? So first step is importing the necessary libraries. Now, from scikit model selection, it imports train test split. From scikit-learn model import, it imports logical regression. From scikit-learn matrix, it imports accuracy scores. Now, these are all predefined functions, classes, algorithms, which are there already available in Python. Once you know the task of each and every one of them, you are able to perform your desired task. So, train test split that you see in the first line is a function used to split the data set into training and testing for machine learning. Let's say it will take 0.2 part of the data, 20% of the data for testing purpose, and the remaining 80% would be used for training. Logistic regression is a class from scikit-learn linear model, which is used to create logical regressions, which is a type of linear model used for binary classification tasks. And accuracy score, the function from scikit-learn matrix calculates the accuracy of the model. Because we also need to evaluate the model, right? That we discussed in the previous slide, step number 6. For that, we need accuracy score. Once all of that is imported, it will start splitting the data set. The data that we have provided in the form of emails or whatever information we have provided, it will split that database. Now in the next line, if you see, assuming the data is loaded into X features and Y variables. It's a commented line. It is not used in a code. It is for our own understanding. X train, X test, Y train and Y test, where X denotes the features and Y denotes the labels that we discussed, the inputs and the labels that are provided in supervised learning. The X variable represents the features, input data of the data set. The Y variable represents the label or the target value that we want to achieve through the data set. The test size, which is given as 0.2, is the size of the data set we use for testing purpose. So 0.2 means that 20% of the data and 80% is being used for training. Random state is equal to 42 is a parameter that ensures that data is split in a reproducible way. By setting a fixed random state, you can get the same split each time you run the code. And then comes the next part where we have mentioned the model. This is the training part of the model that comes into picture. So logistic regression, it creates an instance for logistic regression model. Model is equal to logistic regression enclosed within the brackets. And model fit X train, Y train. This method trains the model using the training data. It finds the optimal parameters that best fits the relation between the feature X train and the labels in Y train. All these are predefined modules that you can use in Python. If you go for C, C++, of course, it's going to be a huge line of codes. But in Python, you can achieve it with simple English written language in much less number of lines. And final step is making the prediction and then the evaluation of the model. The prediction model, this method is used to train models to predict the labels of the test data, X test, and the output prediction is an array of predicted labels corresponding to the input features in X test. And finally is the accuracy score, based on which we need to decide whether more training of the model is required or not. And that's how it keeps on improving itself. This could be very technical, but it's not very difficult. I mean, it's achievable. That's not a issue. Same thing goes with unsupervised learning, but here we are taking an example of grouping the similar customers together for a large target marketing audience. And the data collection step again, which gathers the customer data, including demographic information, purchase history, and other relevant features. Again, the same data processing. Again, we will select a suitable model for it. Again, the model is trained, and again, it's going to visualize the cluster. So that's where it differs from the supervised learning algorithms. Again, we have a small code where it is importing the k-means algorithm, and n cluster 3 means that the data set is split into 3 clusters. So based on what numerical value you give, it will split the data, and accordingly the testing and training is done. And then comes the deep learning with Python, the neural networks. Understanding the basic concepts of neural networks, including layers, neurons, and activation function. TensorFlow and Keras, we have already shown in the previous slides, which is to learn how to build and train neural networks easily using TensorFlow and Keras libraries. And image classification, that is convolutional neural networks for image classification tasks. We also have a code for deep learning. You can see we are using TensorFlow library here. And that's how the very basic code of deep learning would look like. And for unsupervised learning and for the supervised learning. So these are a bit more technical terms. I will not go much into details of it. But this is to give you a very start of everything, like the header of everything, and to give you a path where you can basically start exploring these concepts on your own based on what you want to achieve in your fields. You can start with learning Python. You can start with learning algorithms and machine learning and artificial intelligence. Now, considering the Python, I would like to invite my partner, Mr. Manoj Das, who is going to give you some basic technical aspects of Python to start with. Yeah, thank you.
Hello. Good afternoon, students. Am I audible, right? Okay. So, okay, okay. So let me ask you one question. Like, what do you know about Python? Means AI/ML is very vast, but what about Python? So, are you aware about Python language? You are means friendly with Python coding or not? I just wanted to know. Yeah. But do you have some experience in coding in Python? Okay. So many of you, like I can see, just don't know Python, right? Okay. So Python basically it's a language like it is not just only a language. It's a basically a very powerful tool that may become a backbone of so many industries where we can industries can uh, means from the web development to the web development. It is a very powerful tool that has become the backbone of so many industries, from the web development to the data science and in artificial intelligence and so on. Like Python's basically its simplicity and elegance have made it the language of choice for all the developers, beginners, and programmers. Whether you are just a beginner of who is starting coding or a expert who want to expand his particular existing skills, Python offers you all the things like it provides you the ecosystem, rich ecosystem where you can empower your skills and uh, and bring all the ideas to your life. Uh, it also allows you to experiment, innovate, and solve the real world problems with remarkable efficiency and accuracy. So I'm not going to, due to time constraint, I'm not going to the history of Python, how it will evolve and how about its creation, but definitely I'll go with all the basic concept of Python today. And if you have laptops or anything, I'll go through the installation of Python, then how we can interact with Python language and how to code for a sample programming. So let's get started with the Python. Okay. Why you we use Python for all the language? Because it is very compatible to all the platforms. Means you know like we have so many OS systems, operating systems were used, like Windows, Mac, or Linux systems. So Python is compatible to every platforms. Also, it compatible to all the interfaces with similar way. Means for OS Python is different and for Windows it is different and for Mac it is different. No, it is very similar to all the platforms. So that is the beauty of Python. So also what means Python, what Python provided to us, like it is very easy to learn. Easy to learn means uh, easy to read, easy to write. The codes are very simple, very high level. High level language means it is human readable format. Means it is very close to human readable. And if Chetan shows you some codes, by just you even if you don't know the code, what is written and what is the output, but at least you can understand the codes, what is written. So very simple syntax, very simple. It is follow the accurate indentation of line indentations. So these are the features make the Python easy to read and uh, easy to maintain. Means it is easy to write, and what you write whenever we execute and certain syntax error is comes in, so it is easy to identify those. That is called debug. Debug method is also very easy in Python. Also, it is very portable, quick, since very rich libraries are available in Python in all environment. Like Python is used for backend, used for web framework, we use for artificial intelligence, and also for data analytics or data science. So every area, so many libraries are available in Python. So see, why why learn Python? So it is, I have already explained, like versatile, large community, and easy to learn. So versatile means it versatile to means every platform. Large community, we have large community in Python where we have large number of libraries are available, and it is also easy to learn because of it is simplicity. So if any one of you have any laptop, then I can give you the installation method, like how to install this Python. Otherwise, I'll share this particular PPT presentation where we have given the Python uh, link, how to download it and how to install it. Currently, we have Python 3.12.5 is the latest version of Python. So you can download it, and once you complete the download, Python itself gives you one IDE to write the code. IDE means it is the interface or console where you can write the codes, but it is not so user friendly. That's why some popular IDEs are there. IDE means PyCharm, VS Code, Jupyter Notebooks are such IDEs which are uh, very rich and with integrated development environment they provide for Python particularly. So it is very easy to code the multiple codes and create a project in these IDEs. So once you install all the Python, then the first program is like Hello World. Hello World. If you see, means in the console, Python console, if you simple print Hello World with this simple bracket, the result will be Hello World. And here we use print function to execute the code. And inside whatever message we are written, that will be displayed on the console as the output. In a programming language, we have definitely we have basics like variables and data types. The variables includes, actually, if you see the variables, what is variable? Variable means something we assign some data, or something we store the values. That is called variable. And the data type, what kind of data we are storing in the data type, in the variable, that called data type, right? Data type, if you know, like there may be number, maybe string, maybe something else. So here data type can be divided particularly like primitive and continuous. Primitive means individual data values are stored in a variable, or continuous can contain multiple values in a single variable. So in primitive type, there are some types of data types, that is integer, float, boolean, none, and strings. And containers, it include list, tuple, dictionary, and set. You know operators, right? Operators is nothing but to do some operation. We have multiple operators in Python: arithmetic, comparison, and logical operators. Arithmetic operator, what is means you know about it, like addition, subtraction, multiple, and divide. And comparison operators is equal, not equal, greater than, and less than. Also, logical operator includes not, and, or. These are the operators which are used in the Python. If you see the example here, we have stored a value 10 to a variable a, and in b we have stored 3. If you simple print a plus b, it will do the addition and give the output of 13. And same with the second statement, print a greater than b, means we have already assigned a is 10 and b is 3, a is greater than b. The logical operator is means should be a greater than b, that is true, right? So the output will be true. Okay, so then Python control flow. Control flow means whenever we write some statements, we write some different code or steps to include. But when some steps are bound to a condition, means if some condition are achieved, then only those steps should be executed. That is called control flow. So in control flow, we have some different things like if statement, loops, for loop, and while loops are there in Python. So if statement, if you see here, some from here, we assign particular if age is greater than 18, then print you are adult, else print you are a minor. So this is a control statement. If you execute it, then it will print something whenever if we assign age to anything. We assign age 18, so it will keep the proper output as per the condition. And loops. Why we use loops? Loops is something like if we perform an action on a repetitive way, we need loops. And the basic difference between for and while loop is while loops, if you give the range, means the loop should be iterate for some range, like we have given the range of 5 and assign I equal to some value, then print I. It will write, if I assign I equal to 1 and in range is 5, print I, it will iterate 5 times and it will give you the result like 1, 2, 3, 4, 5. But in case of while loop, it first check the condition. That condition should be true, then only it will go and iterate and perform the action. Such as like is count equal to 0 while count less than 5, print count 1 and plus 1 I. So here if we assign I equal to 1 and the counter will be 0, once it is executed, it should check if the variable is 0 or greater than 5. Then only it execute the while loop. Okay. So in Python data structure, like I have already told you, these are the list, tuple, dictionary, and set are the containers which store the value. List is something is ordered, mutable collections of items, such as if I assign a variable fruits, apple, banana, and cherry, and with a square bracket, this is the syntax in Python. And if you want to print fruits and within square bracket you mention 0, 0 is the index value or the pointers where the apple is there, means the index value should be 0, 1 and 2. It starts from 0. So what is mutable? Mutable means something we can change. We can change the items, means whatever we assign to fruit, we can change in the program. But tuples are ordered immutable collections of items. So tuples are immutable means this cannot be changed, order cannot be changed, or that will be once it is created, that is cannot be modified. So we assign some, like we can assign coordinates variable like 10 and 20. Like this, we can have this tuples. Dictionary. Dictionary is the key value pair, unordered, mutable, such as if I assign some name to name, means if you see name is a key and value is Alice. And same thing like age is a name, uh, age is a key value, and 25 is the value. So if you print person name, then it will give you the exact which pair value. And set are also one type of containers data type which unordered unique items, such as if we assign some number like unique underscore numbers 1 2 3 and again 2 1 which are duplicate to it. When you print this particular variable, it will give all the unique values. Functions in Python, particularly it's a block of codes which can perform some specific action and give you a return statement. So in return statement, you can assign to a variable and you can use it further. So this particular return statement, sorry, yes. Okay. So function is a block of code, whatever we are written, like it execute and gives us a result. That result we can use in a variable and we can use it in further code. So that is and to define a function in Python, like def is the keyword, then followed with the variable function name, then we can give the input to it. Right? Acha. Okay, these are few Python libraries we have, like NumPy, Pandas, and uh, NumPy is for numerical operations, and Pandas for data manipulation, and MATLAB for data visualization. And there are so many libraries are available. When we install it, by default, some libraries are already uh, download and install in our machine. Otherwise, some particular areas we need to install the different libraries from our own. And if you see one example like import math, and we need to find some square root of a variable for a number. So we use math is a library, and the method is the square root. The math dot square root and the values, if 16, then output will be 4. For some file operation, uh, we need to open a file, read file, and write file in Python. For that, with open is the command syntax. File.txt is the file name, and R stands for here read. For the read operation, we need R, and the content is the variable where you load all the file details, file content in the file.read method. And when you print content, it will print all the data inside the file in the console. Same with writing a file with open, and W stands for write. So file.write hello world, it will print everything in the file. Exception handling is something like whenever we run our code and we don't know what will be the error or it will be success or failure. So error handling is needed because we need to identify where the error is. Okay, so if the script is smaller, then it is okay. But if the script having line more than 1,000 plus lines, it is very difficult to identify where the error is occurred. So in Python, there are some predefined errors, and we can use our error handling of our own. That is called user-defined errors. So here is the sample example of error handling with try and except block. So here we can identify if in the code you are giving input to divide one number to other, and that number will be in the result you see that number will be 10 by 10 divisible by 0, and it will give you an error, right? So that error can be handled by this method. So there is one sample program in Python. Okay. It is a very basic program to calculate the average of number. So if we uh, if we means a list, we can add, like if a list, if we see a number, a variable, and we add some more values like 10, 20, 30, 40, and 50. These are the numbers we have added in the number variable, and we need to calculate the average of it. Then we can define first in def keyword, then calculate underscore average will be the function name, and the numbers will be the input. There are three variables we have created. This is the total, the sum of numbers. Count is the length of numbers, and the average. Average is the total divided by the count to calculate the average. So here, if you see after initializing all the variables, we have a return statement average. Average is another variable where we are getting the result of that function. So how to call this function from the main program? So here, if you see the list number we have added, and average is the function name and numbers, and print the average of the list numbers. And here, if you see avj is the number we are getting from the function. So that is how we can calculate and we can call a function from the main program. As this one is for AIML, I have write I have written a sample chatbot script for you. Let me show this chatbot script. It is very simple chatbot script, and this chatbot script I have written in the NLTK, that is Natural Language Toolkit. This is the main library I have used, and here importing some chat and reflections. If you see the pairs is the variable where I have added so many responses, so many pairs and its corresponding responses. It is the interaction between chatbot and you, and which is hard coded. It is a very basic chatbot we have prepared for you. So if we run this, this is how we are getting the responses from chatbot. Like see, here is the hi, and it is corresponding response is here. And another thing, so this is how the chatbot works and give the all the corresponding responses. But it is hard coded, and we can make it dynamic as we learn more and enhance our chatbot. So in the chatbot, like if you see, we import the libraries of NTLK, Natural Language Toolkit, and the pairs variable contains the list of all the patterns and corresponding responses. Each pattern is a regular expression, and the response can be include placeholders like 1%, which refers to a particular method in the pattern. Then we initialize the chatbot with some command, and the conversation started once we executed the code with chatbot.converse method. And you can enhance this chatbot like use machine learning models, integrate with external APIs, and add context awareness. And you can enhance this chatbot as per your requirement. Thank you, but it is a very basic Python concept I have given to you. But definitely, there are so many advanced Python concepts are available, like clashes, like other things. We need to learn more. So definitely, we'll help you out. Means any questions, anything, we are ready to help you. And thank you all for.
Thank you, Mr. Manoj, for that insight on Python. So I'll not go much deep into it. These are just some basic slides to tell you that what are the applications of AI you all can see. It's healthcare, finance, autonomous vehicles, and natural language processing. Of course, we have pros and cons for the AI, like it's efficient. Uh, we have improved decision making, it's cost saving, and it's available 24 into 7. If we talk about the cons, of course, the job displacement is something that we all have to address. It's a bitter truth, but once we are the people who can operate with AI, we can, of course, move a smooth path. And ethical concerns are obviously there. We all hear about the fraudulent transactions, the fraudulent incidents that happen. So that is something that is also being addressed uh, in the AI. So every good thing, of course, it comes with a little bad, and we have to address the bad as well. And technological limitations are still there. As I told you, still the machine consciousness and sentience is required to be achieved. So we are still very far behind. And in the future, we leave it to people like you, the fine people, and the future generation to explore these things and make new discoveries in AI and ML. We all know AI is used in our daily lives, like smart home devices. We have personal assistants, we have online customer support, and recommendation system. We can consider AI as the new digital species that is living among us. It coexists, and we have to learn to live with it, to operate with it, to deal with it. And of course, we have future trends in AI in healthcare, a more advanced technology in robotics, in ethics, and quantum machine learning as well. These are a few resources which are available on the internet. You can refer to the official website of Python for its documentation, for installation. And there are online platforms available for ebooks, which we have already shown here. So thank you very much for your time, guys. And with this, we sign off. We hope that you liked it. And again, this is not the end, it is just the beginning of it. It is the very tippest of the tip of the iceberg, and there is a huge deep down iceberg that still needs to be discovered in it. With this, I sign off as Chetan Arora. Thank you so much. You have been a lovely audience.
Acha. I would request Manwat sir to please present a moment of appreciation. Rahul, please. Manoj Kumar sir, please.
It's a really very tedious process for us and non-coding persons. Hopefully, we'll ask them that they can ask us to give a full place of write-up so that we can go through bit and bit and we can do by our own coding using that one. I should thanks Manoj Kumar Das and Chetan Arora. Please come to the stage. By the way, one more thing that I should thank to and Miniway System. They sponsor us for this conference. Sorry, this STPP. Thank you so much for attending here. Be here for another 10 minutes. Let me complete my talk. Then I know you are getting tired, so you can go for a tea break. Pen drive. Sorry, everyone. Um, After morning talk, it is very difficult for me to give this talk in front of our Alankar sir. But I try to give something and try to correlate what is the analytical modeling and data driven modeling and why you are going for it. Okay. By the way, let me tell you what make me to arrange this STPP here. As the last talk, I want to share with you what makes me do. So self motivation. I always tell my students that be self motivated. Self motivation means first when I finished my BTech career, then I got a job in software industry, Tech Mahindra. There I found lot of coding I'm doing, but that coding I didn't understood. Only I'm doing for other people and very simple codings. Then I got bored of that. Then I went to some core sector. Core sector in the sense that is a public sector, I can say, of fully core where the steel they are making. RINS, Bharat Rashtriya Ispat Nigam Limited. But there I found only one thing I'm doing and without taking any other new development. And that our industries are not so much automated. So there I thought, let me do some new. Then I joined Bhava Atomic Research Center. There I found basic research, understanding the science and developing new things. So that made me how to make it my software skills and my core skills as well as my basic research science skills. So this together, these three, I thought let me arrange this one to motivate you people. That's my first motivation or self motivation. Then second motivation is that national level. National level, our honorable prime minister always think that we should work or we should step into the field of world where the new things are coming up. So they are really praising us to do all this type of small AIML coding and all. So that's the second motivation. And third motivation is international level. International level where we are not standing. If now we take the step, then tomorrow we can do all this. We can step much more ahead than the foreign people what they are doing. So that motivated me. So hopefully you are also something you get motivated and do by yourself. So let me show you why this analytical data-driven modeling and the experimental attributes and why all this compressive approach we have to do. So there are 4 pillars I can say here. 4 pillars means one is metal properties and behavior. We should know what is the metal property and what is the behavior of the material. This is the normal practice to use before anything. Then second pillars I can say metal design. We know some properties or behavior is required, so we can design some material. Then third, multi-scale modeling. Multi-scale modeling, what is do? Now we design some material. So we should understand its basic concept, where it is used, how it is used, and how we can use. Then next things, the application in the industry. We call it automation in the application, or nowadays you can hear about 4.0. That is the industry 4.0. So they are trying to automated the industry from the starting from the scratch or taking the raw material to the finished product. So for this all things, metal informatics or data-driven approach is required, which in this field, I can say Alankar sir is the one of the renowned person in the India. So what we're really seeing, we're seeing, let's say 3 things we're seeing. One is the nanoscale, one is the microscale and the mesoscale. Mesoscale you can see by your eyes. Microscale, I can say we can see some something like little enlargement or some eyeglass, something we can see. But nanoscale, if you go, we cannot go. Where you can see the atoms. But from the atom itself, we can correlate from the atom to the end behavior of the material. So here I have shown few examples here. Can I have the pointer, please? See here can visible here. From atom we can take some lattice. This lattice itself, it can show what is the strength behind the material. How we can say, we can see some closed pack lattice, also open pack lattice. So that deformation behavior is different. Next, let me come to the effect in the material. So I have written here 0-dimensional, 1-dimensional, 2-dimensional. Hope you know that 0-dimensional is some vacancy over here. Then 1-dimensional go for dislocation, which is the minimum. Okay. Then coming back to grain boundaries, you can see where we are seeing the microstructure over here, and beyond the microstructure, something like we can say some precipitated edges and texture. Then after that, we are getting some surface cracks and all. Don't you think that all these microstructural attributes is giving us minimum criteria to select or to simulate to understand the prediction or to predict the material behavior? So in that context, let me show you, I am showing you here some atomic representation. Now atoms are arranged like this. So what I am showing it here, let's say this is a simple cubic structure. Now the same simple cubic structure, let me rotate it little bit more. So we call it that 111 planes are facing somewhere. Now 110 plane is facing. So this is a cube I have taken. So these atoms are arranged. So you can see this fashion. Now we are going for a n number of planes arranged in a cube. I have taken a cube here. So each individual things, we call it single crystal or grain. And each having we take it as polycrystal. So most of the material in the universe or in the whatever you're using, these are polycrystalline materials. So now again I'm showing it. So let me take a atomic plane. The same atomic plane I have taken. Now what is the concept of different planes in a given crystal or orientation? So now I let it made it little bit of denser. Okay. Now further denser. So now which plane will be easily deformed? So let me sleep someone on plane, another plane. So you can see here the bond breaking is little bit difficult, whereas it is easier. So though is dense packing, so it is easier for deformation. So that context, we can develop some metal plasticity modeling. So what my metal plasticity is telling, we have some orientation, and I'm showing some dense pack plane. Dense pack plane in this different orientations are present. So here showing it where this how this can be deformed and which direction it can deform. So this is a stereographic projection. Hopefully I'll keep on explaining all these things. So then how the strength of the material, Hall patch lesson, if a polycrystalline material, we are taking a Hall patch lesson, just yield strength is equal to sigma to the d to the power minus half, directly proportional to d to the minus half, where we can take the modified Hall patch lesson and individual plane contribution, and systematically we can derive this shear strength. And now we can see some single crystal which will take, and we got it is the single crystal pillars. If you deform these pillars, we know the single crystal how it is deformed. Okay, what is the yield strength, what is the metal strength of this crystal? Now this crystal, after this we are getting some mechanical properties over here. Now this mechanical property you can correlate to each other. Now what I'm showing it here, I have taken few orientation because I know the single crystal and that interface. If I'm taking it, so yield strength you can see the variation. So yield strength is different over here, but this variation is different. So individual orientation having different strength and individual orientation interface, if you're taking, that is also having different strength. So now the first pillar, what I'm telling, metal properties and behavior. If I have some orientation, n number of orientation. So let's say n number of orientation. So I'll get n number of mechanical properties variation. Now n number of I got. Now number of possible interface. How much possible number of interface it will be there? This will be 2n into n minus 1. So when n tends to 0. So whether you can imagine we can getting these properties, it is really became very much challenging. So what I need, we need the simulation or we need a equations, what everything can be together, can be taken out, and that can be giving you the proper result. So data driven modeling is one of the important factor. Similarly, let me go fast this time because I have very less time. So now metal design and discovery. So these are having alloy design, process design, surface design. Alloy design means what? We are making a new alloy using the statistical thermodynamics. Otherwise, you know what is the thermodynamics function as used for different element and what is the parameters. Then which process we should make it. Then further going to surface design. What the surface should be harder, softer, or having a high ductile materials. So these are design. So what this is? So a range of metal we can take and using this, which is the cost effective and processing method and microstructure mechanical properties, these are we can generate a database. How we can generate a database? These all things we can take, but lot of database are available for a given things. So this is the one of the important factor I'm adding it here, which will help us to together make one real nice database from which we can extract the matter and design our materials. So let me give you some example here. Now here I have given some different types of steel. So we know some steels are there and they are having different composition. Slightly variation of composition itself making an impact of the metal properties. So here this see, I have given some example here. Let's say I have taken 5 elements and I'm changing. So these 5 different properties having some, they are changing. So and the phases and that room temperature phases are changing and that also impact on the metal properties. So what we are doing more here now? So we are taking some thermodynamic simulation and getting some database of thermodynamics of what phases and what phases will form and how much phases will form and what processing condition we have to take. Then using this total process, then one combinational matrix we can derive and we can get the best practice to form this design this alloy. And then processing we can take the different types of deformation phenomena in the strain and high temperature conditions. So we can understand at what temperature and what strain or what way we can get some high efficiency zone or domain for the material. Now further, this hot rolling, warm rolling, and again we are giving some intermediate annealing treatments. Okay, then that also giving some properties of the material. Then these are giving some resulted microstructure over here. These resulted microstructure with some different cooling effect or heating effect, we are getting some different microstructure, and these different microstructure attributes will add different types of property of the materials. So now again I'm coming to the second pillar over here. So for the material design and discovery, so we understood that there are several parameters exist for a processing or choosing a material and going for a last or resulted microstructure. So if number of parameters is n, so number of possible interaction is np n. This is probability for this is the npn and n factorial. So when n tends to infinity, that time also it is very difficult to discover a material which you desire for. So same thing I'm coming it back. So data-driven modeling is one of the easiest way to get the resulted function. So multi-scale modeling. Multi-scale modeling is talking about different scale. I talk about nanoscale, microscale, mesoscale. So this different scale having different impact on the material. So I have taken an example for 2D and 3D of a grain boundary. So grain boundary is the minimum entity on the material which gives a lot of good effect and bad effect to the material. So what it will do, it will stop the dislocation while going, and then it will enhance the strength. So the strengthening mechanism. And this is why it is important. This is toughness will increase as well as it can enhance the strength. So that's why we just read always this grain boundary. So this grain boundary you can see here, I have shown a single line grain boundary, but it's mostly look like in 3D a plane. So each plane having a different slip line moving from one grain to other grain. And this depends on the interface plane. So role of grain boundary that consists of this stopping this dislocation and offer the resistance and enhancing the strength. Now I'm showing it here. See, if I take a grain plane here, this plane are showing that what is the slip direction over here and what is the slip direction over here. So given a plane, there is two slip directions, and I told that either of planes having a n number of orientation can possible. Whatever I'm showing it here, mostly I'm talking about this one, a plane in a conventional way. But actually, what is there too? It is a curvature or different planes in a single grain boundary can exist. So each, now I'm showing it here, a straight boundary and a curved boundary and a highly curved boundary, multiple curved boundaries. So you can see a slip directions or slip movement. Here, it is stopping or slip direction, stopping slip, slip is stopping. So you can see the colors over here, and slowly it is going out. Although in single curvature, it is the slips are coming this way. But in multiple curvature, you can see the uniform distribution of slip. How this is occur? So these are this type of things are there where they are talking that plane, if you are putting some stress, the stress can be comparable with this Sn with S0 and some cos square theta. So these are some formulas, basic formulas, which are using in FEM and all. So we know that what is the stress involved in a single this plane. Okay, so we know the grain boundary plane also. So with that we understand we can get what is the plane or the stress distribution over here. Now you can say I have shown you a three-dimensional grain boundaries. So here, though we are telling that it is a plane, flat plane, but you can see there are a lot of curvatures over here. Okay, so this curvature itself, if I'm talking about some factors, these factors are affecting the stress. So this curvature is telling about what is the stress distribution during the grain plane. So it is telling us what is the heterogeneous deformation or microscopic level occurs. So these are one of the factors where what we are choosing for making a designer material. So if we know this type of things exist in the material, and we can do lot of simulations or predict the material behavior. So I'm showing it here. So shown it here. Fourth, a third pillar. Third pillar is multi-scale modeling. So we are seeing a straight line, but it is not really. And atomic structure distribution. Okay, but this atomic structure distribution, you can imagine. Now I'm showing it a flat or straight line. Now it is how much possible? Every each degree, some hundred of different planes are possible, and either side of the grain orientation are possible. So to understand this one, this is a really data-driven modeling is required. Now coming back to if we know all these things, so what we can develop, we can automate our industries, and these will give you a very greenhouse. This will stop the greenhouse effect, and we can reduce the carbon footprints, and we can develop generate a new world for our future generation. So I appreciate when we are talking about AI, ML, and computational modeling, where resources we are using less and identifying the best possible solution for the new future. Thank you so much. So maybe we'll conclude that we'll meet tomorrow from UK. One of the AIML founder, Mr. Dr. Adula Reddy, he is going to talk about all this reinforced learning and all, and he is a material sciences person. So whatever I have shown it here, these four pillars, we are arranging four different types of uh, classes for here this STPP. So they will each and individual help you to understand these four pillars using the data-driven modeling. Okay. So see you tomorrow then. Please join us for a tea. Thank you so much.
I would request Ram sir to please come up and present a moment of gratitude to Manma sir, please.
Here, all the interest are very kind. Thank you for that.
You may please proceed for tea towards your right. Please proceed. Thank you. This will be